Hello and welcome to this video where we'll come into pipelines and grid search. This is for us to find the right hyperparameters and finding the right model so that we can get the model that have the best metrics for our given problem. This is a way to systematically find the right model with the right parameters. This will be quite interesting, and since this will be quite short video, short on theory and then short on the code, I will put them together into one video. Here we are in the slides. Searching for the right model with the right parameters require pipelines and grid search. Note that this is just one way to do this. We have other types of searching. There's also randomized searching, but one way is using the grid search, which is the exhaustive search method. What we do is that we have which model to choose and what hyperparameters? This is the question we want to solve. For example, classification, we have many algorithms. We have, for example, logistic regression, we have KNN, we have random forest, we have XGBoost. There's so many models. We don't know which one to choose. Each of them have a set of hyperparameters that should be set differently depending on the data set. It's also the case that we don't know which hyperparameters to choose because that is not clear either. We need to test it out. We need to, based on the testing, the validation data and the hyperparameters, we need to test which one to choose to find the ones that are the best. For doing that in a systematic way, we have something called a pipeline. For example, we need in our pipeline we need to scale the data and then we need to send it into an algorithm, for example. Then later on we can scale the data and put it into algorithm N. We have several algorithms to test it out, to see which algorithm to pick. We have parameter 1, parameter 2, etc. to test out. We go and test out, for example, for KNN, we can test out the number of neighbors and the more parameters, etc. For example, for elastic net in logistic regression, we could have alpha and lambda. We could test out and put in several different values of them, and doing what it does is that it does cross-validation. We test it out and see which one that performs the best, and then we compare that one to KNN, we compare that one to random forest, decision tree, etc., XGBoost, etc., and to see which model to pick. This is the param grid, it's called. We have different parameters for in a grid that we need to test. We need to test like first parameter 1, value 1 against parameter 2, value 1. Then first parameter, same value as the first one towards the second in param 2, etc. So you do an exhaustive testing here in order to find the right set of parameters to use. For each pipeline, each parameter combinations are tested using k-fold cross-validation. This is the idea. Then we compare the different metrics to pick the model with the parameters that we want. Okay, so now let's move on to the code, because this, as I said before, this is quite short in theory. We go into the code immediately and work this in practice. Here I am in the code. Let's start with the terminal. UV-VNV to create a virtual environment, then source then bin activated, then UV pip install. I need install scikit-learn. I need IPy kernel, I need pandas, and I need lib. That is it. Maybe I don't need matplotlib actually, but it doesn't matter, it's okay. Okay, so then we'll start our grid search. .ipnb. Here I will start my grid search CV like this for hyperparameter tuning. We have here grid search and change this to Python. Let's start up from scikit-learn datasets. Import and load, not breast cancer, let's take load wine since I've used that before. And then import pandas as PD and then import pi as np. Okay, that is it. I will start with this. Then wine equals to load wine, and then we will have df equals to pd.dataframe and we want to have wine.data. If you have seen my videos before where I've worked with load wine dataset, I've done some exploratory data analysis already on it, so then I know how to pick out the data. But I won't do the feature selection as I did in that video with KNN. Instead, if you want to learn more about that, go into the KNN video. But for now, I'll just use this as it is and pick out the data frames, feature names. Then we have df like this. This is the data frame. I will do pd.concat as well. I want to concat on df, comma, let's see, we need to have a list, df, comma, pd.data frame, and we'll have wine.target columns equals to wine class, so that I'll just put in the wine class in the same data frame so that we're used to how we used to work with pandas. Axis equals 1, and let's see df. Now we have 14 columns. Last column is wine class. Perfect. Okay, so let's see df.head instead of the whole df. Okay, so now let's do some train test split. Train test split. Okay, so let's do from scikit-learn.model selection import train test split, and then we'll have x comma y equals to df.drop wine class, and then we'll have axis equals 1. Then we'll also have, this should be in parentheses, not brackets. Let's change that one like this, and then comma df wine class. Then we'll have, I need to copy this one so that I don't mess up here. We have xtrain, xtest, ytrain, ytest. We split it up. What you can do is xtrain.shape and xtest.shape, just to look how it's split. Okay, splitted 50-50. That's totally fine. Let's go into our pipeline now, our main attraction for today. Pipelines and grid search CV. Okay. Let's work with this now. From scikit-learn.model selection, note that we're selecting models. That's what the grid search is doing. Import grid search CV. And then from scikit-learn.pipeline, we need this, import pipeline. Then from scikit-learn.preprocessing, in our pipeline, we'll place in our standard scaler as well. Preprocessing, import standard scaler. Then from scikit-learn.metric.neighbors, import kneighbor classifier. Then from scikit-learn.linear model, import logistic regression. Okay, so now we have two models and we have one scaler to work with, using this to create our pipeline. We have scaler equals to standard scaler, and then we will have the pipe. We have different pipelines. We have one pipe KNN, we have pipeline here. For this one, we will put in order to do the pipeline, you need to have a list of different steps in the pipeline. The first step is the scaler step. This is the name that you should use. You can use whatever name, but it should be a name that is easy to know what you're referring to, because we will reuse it later on. Now we have our scaler here. We need to place in the scaler object, the instance scaler. And then is the next step. What we place in here are tuples. You need to have a list of tuples. Then you have tuples, and then you have the next tuple. KNN, we put in kneighbor classifier, this instance. Since I'm using the callable, it's an instance of this class. Now my pipe KNN is finished. We can look into pipe KNN. It looks like this is a pipeline of standard scaler with these types of parameters. Then we have KNN and this type of parameters. This is the default parameters that it uses. That's why you have it like this. This is the pipeline KNN, but we will have more pipelines. We will have pipe log regression equals to pipeline. Here is a list of, let's see, of tuples. Then we have scaler, comma, scaler. Then we have the next step is the log. Here we'll have logistic regression. Okay, logistic regression, you can have some default values put in. Let's put in some default values that we put in Saga, for example. This is a way to, if you look into the documentation, you'll see that here the different solvers should be used. And Saga is one of them. I won't go into exactly what that means, but you can look more into detail. There's some kind of stochastic gradient descent. Then multi-class OVR, one versus rests, max iteration, 10K, and then penalty, I'll pick elastic net. Okay, so this is my pipeline logistic regression. We have a scalar first, and then we have logistic regression. Okay, fine. Then it's time for, we can look into that actually. We still have the standard scalar with these parameters that looks like this. Then we have logistic regression with these parameters. As you have seen, we have penalty elastic net, which we have picked and solved. All the red ones are those we have picked. All the other ones are the ones that are default. Okay, great. Now it's time for, remember in the theory that we had, so we have our pipeline, and in our pipeline we need to specify the parameters to use. That is the param grid, so parameter grid. We have param grid, KNN. To specify this param grid, we put in the dictionary, and the dictionary of the name of the instance, the name of the step. You see this step here is called KNN. Then we place in KNN because this is the step. This should be so this is the step name. Then you need to take underscore and you put in the parameter that you want to tune, the hyperparameter. As you see in here, for example, K neighbors. And we see we have n neighbors, so this is the parameters. Then we take n underscore neighbors. This is the parameter to be tuned. This is the hyperparameter. Then we can have colon. Which type of values do we put in? Here we put in a list of range 1,50. This means that we will have 1, 2, 3, 4, 5, 6 to 50. Neighbors. I can take comma 2 to have step 2 so that we have only the odd ones, for example. Then we can look into this param grid to see that it looks like this. Actually, I can take a print here so I can see it in this way instead. You can see here it's a dictionary. Let me check. Type param grid KNN. Yeah, it is a dictionary because I created it as a dictionary. I was a little bit confused. Now I'm not confused. Okay, so this is the dictionary with this key, and these are the values. Let's create our param grid for logistic regression. It's equals to another dictionary. Same here. It's called L1 ratio. I will tune this one because this elastic net we're working with. For the L1 ratio, I'll do np.linspace between 0, 1 and 20 values. You can look into this one, param grid log reg, print this one. It looks like this. Yes, this is the key and the value is an array here, the NumPy array. Okay, now it's time to use this in action. Let's do classifier KNN equals to grid search CV. Here we put in the estimator. What should it be? It's the pipe KNN. Then we have param grid. What should that be? That is our param grid KNN. Then CV is cross-validation. You have different folds, and we can pick 5 as default. If you put more, it will divide the training data into more sections, and it will take longer time to run. 5 suffices quite well, I think. Then the scoring. What type of scoring do you want here? Since we have a somewhat balanced data set, as we've seen before in EDA in earlier video, we can just put in accuracy here. So that works quite well. This is our grid search for KNN. We can take a look into classifier KNN and see what it looks like. It's a grid search CV object now, or instance. Then you see this grid search CV. It has parameters. We have this estimator, this pipeline here. This param grid is the one that we put in. Then we have scoring as accuracy. This is the one that we want to optimize. We want to have as high as possible. So maximize that one, and 5. Those are the things that we have picked. Then we have the estimator. You can see here the standard scalar, and you can see here's the neighbor kn. You can see the whole pipeline here. This is quite a neat way to represent it when you're in Jupyter Notebook. Then we will do the same thing, but with search CV, but not pipe knn. Instead, we'll have logreg. For logreg, let's take in pipe logreg, and then param grid logreg. And we can have same thing here. Now it's time to actually do the fitting. We have classify knn.fit xtrain. Note that we don't need to scale it. Why? Because our pipeline already includes the scaling part. Now we don't scale it. We put in the original xtrain, and then we put in the ytrain, and then we do a similar thing. We can do this one first, actually. We can do one step. Okay, do this one first. We have done the classifier knn.fit, and then we do classifier logreg. Oh, I want to have a small here. Logreg.fit. Here is the same xtrain, ytrain. Let's see, classifier logreg not defined. Yeah, because I didn't run this one. Run all. Oh, and you can see there's a lot of warning because here multi-class was deprecated and will be removed. Use one versus rest instead. Leave it to its default value to avoid it. Let me see if they have something for multi-class here. Okay, yeah, they are deprecating it, so I'll just remove it. I think I don't need it. Run it, run all. Yes, it has trained. And interestingly here, now you can see here, actually we can see it directly here, best estimator. You can see here the parameters. Let's see. Yeah, here they have found it. You can see the L1 ratio that it found that was the best is 0.31. This is the one that it has found, and all the rest of the parameters. This is the, based on the param grid that we placed in, this is the best estimator that it found. Okay, good to know. Here for our knn, let's look at that one. Parameters, we can see here neighbors equals 5. Let's see fit. Let's see if we can do classifier logreg dot best estimator dot get param. Okay, so these are the parameters for its best estimator. You can see here's the L1 that we have picked, that it has picked for us. Let's do the same thing for knn and see what we get. Let's see, logics knn. And here you can see, let's see, yeah, n neighbors equals 5. This one was the best that we picked. Okay, so based on this, let's do some evaluation. And to do evaluation, it's same as before, basically from, let's see, change to Python. From scikit-learn.metrics, import classification report, confusion matrix display, confusion matrix. Then we do ypred equals to classifier knn dot predict x test. That is it, because we have trained our model, then it saved the best estimator and it used that to predict the x test. Then we have predicted ypred like this, and what we can do is we do, let's see, print classification report of y test, comma ypred. This is the best that we got from this one. Then we have cm equals confusion matrix y test, comma ypred. Then we do confusion matrix display cm dot plot. Okay, if you followed me in the KNN video before, you saw that one we did feature selection, and that may impact more. Also, it could be due to luck that we got somewhat worse in this case than before. Because the data is randomized, there's a lot of different reasons for why it was better in the KNN. Just the basic model which we used for the elbow plot. Here, let's copy this one. Now let's do for logreg. Let's see, logreg. And everything else should be same, I think. I'll clean this up. Yeah, I think everything should be same. Okay, logistic regression, obviously the winner here with these parameters. Here it classified everything correctly. Yes. Okay, so the question is then, what happens when, for example, note that, for example, this case here. We got the KNN, we got the neighbors to 5, and it found that one as the best, but we don't know if it should be. Oh, and that this one was actually bad. For example, the L1 ratio, we found 0.35. That was the best one. However, if you want to go deeper and get more details on which L1 that should be the best, then you can narrow it down and do another grid search. For example, you found 0.35, but the next step is 0.5, for example. Then you can search from 0.3 to 49, for example, and do more detailed search and see which one it found that was the best. So you can do this process iteratively in order to get better results or more fine-tuned results in case that is needed. For example, here it's totally not needed. Yes. In this video, we have gone through grid search CV and param grids in order to hyperparameter tune different models and then comparing different models using the test data. Finally, we have found the model that is the best for our case. Then when you have done that, the next step is to use that model with the model parameters to train on all the data that is available. Then you can use this for deployment in later stages. I hope that you have learned a lot in this video, and see you in the next one. Bye.